circuit is where the output does not depends on the value input and the and has a feedback, okay, and also it has a memory. That means it has a memory. How is the structure? Let me draw. This is your combinational circuit. Okay, combinational block. This is your input X and this is your output Y. But when this is only combinational part. When the sequential part come, there is one more thing, storage element. Storage element. What is storage element? That means it stores the memory. Whatever the output of the state, then it stores and then gives the memory to the next state. Then it comes back. This is the feedback path. This is called feedback. Okay.
Okay.
And it goes back again. So the important thing is sequential has two parts. Okay, two circuits. Sequential circuit has two parts. One is asynchronous and synchronous. Synchronous and asynchronous.
Synchronous.
Yeah.
Okay.
So synchronous circuit and asynchronous circuits. What is synchronous circuit and what is asynchronous? Okay, very simple. I made it more easy. It is also called finite state machine. Finite state machine. Okay. Leave. I had to write these things. Okay, let me bring it more here. And let me take this part bit here because okay, it is better. I want to draw a line because I want to differentiate. Okay, so it is also called FSM. You can also call this as synchronous circuit as finite state machine.
Finite state machine.
Yes. And what does it mean? It means there is a clock signal. Clock signal. It means at each interval, at each state, there is a timing. Okay, let's say after 5 seconds, it will go to the next state. After 10 seconds, it will go to the next state. Everything, it is set by a time. Just imagine it is like it works with a clock. So tick tock like this. So timing is given by a periodic.
Timing will change or it's the same, like it's a constant?
No, it is not constant.
Okay.
It's a periodic. I will draw this thing. Periodic signal called clock. Okay. And how does it work? Like let's say this one. Rising is, falling is, rising is, falling is, like a period.
Okay.
So this is the time period T. Okay. From one rising, you can say from one rising is to one falling is. So this is your rising edge. Rising is, and this part, this is your falling edge.
Falling edge.
Yeah, falling EDGE
edge. Okay.
And this is what? This is your clock signal. Clock signal. How does the clock works? Like 0, then 1, then from 1 to 0. Okay. Then wait for some time like waiting, then 1, like 0 to 1, 1 to 0, like falling and rising. So for rising, it goes from 0 to 1. For falling, it comes down from 0 to 1. Sorry, 1 to 0. Got the point?
Yes.
Okay. So asynchronous, what is asynchronous? We studied everything about synchronous. What is it? It has a clock signal. Simple. You just remember what synchronous means. A clock signal is there. Okay.
Okay.
This is the clock signal. Okay. And asynchronous means does not have a clock signal or don't have a clock signal. Okay. And what does it mean? The state can change at any instance of time. Okay, that means we are at a state A. Okay, we can go to state B. It is not time dependent. You can go now, you can go after 5 minutes, you can go after 10 minutes. But here, if it would have been synchronous, then what would have happened? Okay, after 5 seconds, the like signal will go from state A to state B after t equal to 5 seconds. So we set a time in synchronous, but in asynchronous we don't set a time.
Time.
Got the point? So this was the conceptual thing.
Yes.
Then we study about memory elements. Memory elements. Okay, what are memory elements? Just know the definition. No need to like know so much. The elements which store information. Okay, the elements which store information, that is called
Yes.
memory elements. And let me draw something, like just know it, no need to like so much give your brain. This is a time delay. Okay, there is some time delay.
This
Let's
is
say
like a gate.
not a gate, but we represent it as a buffer time delay. Let me tell you what is it. There is a time t. Okay, the signal has to reach the destination from this destination to this destination A to B and time t. But so, like due to some problem in the circuit, it took extra time delta tg. Let's say no delta t. Let's say tg. Okay, tg is the time delay. So it took some extra time tg. So we represent. So all the information will get lost if it is taking so much time. It has to reach from A to B with certain time t. So these information get stored in the buffer. The information gets stored in the buffer. Okay, and this tg along with this time carry the information and to the final destination. So what is our total time delay? It will be t plus at like what time it will reach the final destination, t plus tg, right?
Yes.
Okay, if we have something like this tg, if we have a feedback, let's say 0, we gave a input 0 and we got a feedback, this will be 0. Then, and also let me draw this, just know about it, it is not that so much. This we give an input, this is a feedback, the input is 1, so the output is 1. What does it mean? If input has been constant either 0 or 1, okay, 0 or 1, then for at least tg, This is the TG time, least time delay, I can say. This is the least time delay. So the buffer output will be stable. So will be stable at t plus tg. Whatever the output, it will be not unstable whether we apply feedback or not a feedback. It will be t plus tg. Just a conceptual thing to know about it.
What do you mean? This is stable as t.
Stable? No,
T is
stable
time.
at t plus t. T is the time. This is the total time. It has to, like, let's say the signal has to reach in time t from A to B.
It has
But
delay.
yeah, it has delay to t plus tg. This has to be the rule. Like when we find at this point, the information gets stored on the buffer and the output will be t plus tg. I mean the total output of the time. But I am saying, if we apply with some feedback and we give some input 0 or 1, okay, this is digital system, so we give like digits as input 0 or 1. So what will happen? It doesn't matter, it will stay stable, the output will stay stable with the time delay. This doesn't matter. Just I said, that's why I'm saying it, just
You
to
mean the
know.
output doesn't change?
Yeah, doesn't change. I'm just saying you because these are the memory elements. All these are. These are memory. Like, you just need to know this part. The elements which store information are called memory elements. And this one I said you because if in case this has no possibility of MCQ question, but if by chance it comes, then you can, okay, you studied, it is stable, so it will be again t plus tg, right? Next point is flip flops. What are flip flops? So flip flops are the memory elements. That's why we studied memory elements. So flip flops are the memory elements used in when there is a clock signal, because without clock there will be no time delay. Time concept will come when there is a clock. So it is a synchronous, right? Synchronous circuit.
Yes.
Okay. Synchronous IT. Okay. And then synchronous. Let me write full sentence. Synchronous sequential circuits. Okay. Then it is, you must know, it is a binary memory element. Binary memory element, like it stores, just has 0 and 1. Binary means 0. And able to store single bit. Okay. And timed, let me write it nice, single bit, and timed by a clock signal. Okay. It uses a clock signal.
No, it is completely. That's the memory elements. This, what is this?
Used.
Used in synchronous circuit, sequential circuit.
And this is binary. Let me write it. Right?
This is.
It is
binary memory elements able to store single bit and time
by a clock signal. Okay. And they are made with basic elements. They are made with basic elements called LA. Let me write in Latin. Latches. Latches. Okay.
Okay.
They are made with some elements. They are called very basic elements, which are called latch. So what are latches? Latches. They are simple. They are the building block of a sequential circuits. Okay, they are like building block of sequential circuits. Okay, and it is a bistable. It is bistable. What does it mean from bistable? It means circuit with two stable state. Circuit with two stable state. You will get to know what is state means exactly. When you will do the questions, you will be very clear, like all these things will come, but we will not like read their internal structure, but we will just use it in the question, just use it. So you will, okay, then you will get to know, okay, that was the stable I was discussing, like different states we will use. And okay, maybe next class we will discuss about SR latch, S complement R complement latch, and then D latch. This is important, we will use it many times.
C complement.
Sorry, D latch. Yeah, D latch, and then we will study also SR latch with control, with C control. Okay, and that much. After that, we will discuss about directly the questions.
Hey, the questions from sequential circuits are multiple choice, or because this is only concepts.
Okay,